Hi, everyone, and welcome. I'm Alex. I've been an iOS software engineer over at Fitbit for 3 years now, working on the Fitbit developer platform. And this is my colleague Bogdan.
Hey everyone, I've been with Fitbit in the past 2.5 years. I've been working on the SDK side, meaning the infrastructure and the Fitbit developer platform side running on device and the associated tools. From the team, we also have Andre. Andre will be in the chat. So the way we structured this presentation, we're going to go over the content that we want to present to you, and we will also have a Q&A session at the end, but feel free to leave any questions you might have during the presentation on the chat, and we'll attempt to be responding to them. Thank you, Alex.
Okay, so today we'll be talking about the components we are developing and delivering both for end users and developers. The Fitbit Developer Platform, or FDP as we call it, is composed of around 35 engineers with different skill sets from JavaScript, TypeScript, firmware, iOS, Android, all the way to cloud and automation. We're all working on different components that ensure not only a great SDK, but also an awesome and straightforward experience for our developers and end users. So in order to get to help apps on Fitbit, we first need to understand the infrastructure we have available. So let's start with the app technologies. You can see here that there are three big components. First, there's the actual app code, which runs on the watch using the device SDK, which allows you to create unique user interfaces and access device-specific sensors to deliver the best experience for your users. Then there's the companion code, which runs on the phone. The companion gives you access to certain capabilities that the device doesn't currently support, such as internet access, geolocation, so you can fetch the user's current location or be announced whenever a significant location change occurs, calendar data, in case your app needs to be aware of the user's schedule, and most notably, the companion offers APIs to communicate with the app on device. There are two mechanisms available. We got the messaging socket, which allows real-time TCP-like messaging between the two components. The app needs to be open on the device for this mechanism to work. On the other end, we have file transfer, which allows you to enqueue and send files even if the other party is not running. The companion will be woken up whenever it receives a new file. We also offer a settings component, which provides a visual way for the user to tweak settings for your app. All of these settings are stored inside the local storage, which the companion can access and then forward to the device if needed. So we've been talking about companions, and it would be highly inefficient if the companions would be running all the time in the mobile app, both CPU and battery-wise. That's why we've designed a companion life cycle that would best suit the developer's needs while keeping things efficient. There are a few events that can wake up a companion to enable most common use cases. For example, when an app was launched on the device and it needs to communicate with a companion, when a significant location change occurred, which can be used for refreshing weather data, for example, when the user changes cities. Let's say he's traveling. Another reason would be the periodic wake interval. Your companion can basically tell the system that it wants to be woken up every 10 minutes to refresh its data. The user changed the setting in the settings component. Like the user could go ahead and change the primary color of a clock face. Or, last but not least, the device finished sending a file to that companion. And in that case, the companion can read or upload it to a backend service. An important thing to note is that the companion is completely aware of why it was launched and can act accordingly, depending on the reason. On a more under the hood side of things, our backend components are mainly composed of the gallery backend, and the very generically named install service. The gallery backend communicates with the mobile and desktop gallery to provide the data displayed. It also communicates with the install service, which deals with everything app related, such as staging an app installation, update, or removal, and can also directly interact with the device. So that's some of our internals, but you as developers actually interact with these 5 components and processes. So you can build your app using either Fitbit Studio, our online IDE, or the CLI tools with your favorite editor locally. Once you're happy with your app, you then upload it to GAM, or the Gallery App Manager. This is where you get to show off your app with a cool description and awesome screenshots. Then every app and clock phase goes through a review process, and depending on the result, you can go on and publish your app. Once published, your app shows up in the gallery, be it mobile or desktop, ready to reach the users. So once an app or clock phase passes the review process, it will become available in the gallery alongside all other content created by our developer community. Having this engine open to third-party developers has helped grow and empower an impressive developer community, which over the years has published over 10,000 apps and clock faces. The community of over 6,000 developers constantly produces creative and compelling content. We have multiple programs to encourage these developers and keep them engaged. For example, we have an MVP program which rewards developers who create innovative content in different areas, such as design, functionality, thinking outside the box, and others. The most proficient developers are then invited to join an NDA program, which puts them in direct contact with Fitbit and the FDP team, and lets them work closely with our engineers to develop even greater content. And I think Bogdan wants to talk a bit about the device side now.
Yep, thank you, Alex. So Alex has been talking about the entire ecosystem and the main components of the Fitbit developer platform, and I'll just zoom in for a bit on the device stack. It's a stack, so there are multiple components running on the device which are decoupled or have strict access interfaces to the direct layer underneath or above. At the core of our SDK running on devices is a JavaScript interpreter, which in our case is JavaScript, which is taking care of implementing most of the standard JavaScript APIs. By the way, our developers develop in JavaScript. So it's main JavaScript primitives and types that allow for development in JavaScript. And tied to that is our component of the JavaScript bindings, which basically expose to the JavaScript environment the Fitbit specific components of the device. These components, as an example, can be sensor data, memory access or file accesses. It can offer APIs to interact with the companion Alex was telling you about, and everything that's specific, or many things that are specific to Fitbit devices. And this, the interpreter and the JavaScript bindings are the component which is decoupled from the actual platform it's running on. At this point, the SDK is running on our smartwatch families. So if you're thinking about Ionic and Versa devices, so using a OS abstraction layer, we can differentiate between the devices themselves. So we can ideally have the same SDK and JavaScript engine running on all devices. And it can also gives us easier portability in case we want to enable another platform to run the SDK. And underneath it all is the Fitbit OS. Next slide, please. As I mentioned, for the interpreter, we're using JavaScript. It's an open source project targeting IoT. Right now, it's implementing a specific JavaScript standard ES5.1 plus some additions to it. We're periodically rebasing on top of the upstream JavaScript to bring in the latest interpreter features. The project is written in C, therefore our JS bindings are written in C as well. And we're also maintaining the platform access abstraction, which is a set of APIs for our engine, interpreter, and bindings to interface with the OS. By implementing this SDK on device, we are making sure that the app code, so the app functionality, is decoupled from the OS, so that we're not forced to release new versions of the app only when releasing a new version of the underlying firmware. Next slide, please. So I talked a bit about the code that's actually running on device, but throughout that code, we're also taking care of a set of tools that allow for development of the apps. The entry point in the diagram Alex was talking about are the tool chains we're exposing to our developers, which can be a set of tools that can be interacted with via the CLI. This is the preferred way both for developers and for our developers, so to speak. This is where we bring in the latest features. They are distributed as an NPM package, so that can be integrated easily with the other tools JavaScript developers are using. We also allow the possibility to our developers to develop their apps in TypeScript, and we're taking care of, as part of the tool chain, to transpile that code to a version that's supported by the devices. Also, enabling the options in the manifest and making sure that we're properly bundling the apps so that they can be distributed and installed on our Fitbit devices. Alternative to the CLI tools, the developer can choose to use Studio, Fitbit Studio, which is a browser-based integrated development environment. And they can have this accessible wherever they have a browser. This is sort of like the endpoint that developers interact with. All the communication between the endpoint, which is normally running on the developer's laptop or computer, is interacting with the rest of the Fitbit ecosystem via the developer bridge, which is a Fitbit-specific protocol for the SDK development. So via the developer bridge, we can perform actions such as installing an app on the device, debugging it without having to deploy it via gallery, looking at the traces, looking at the logs, and generally developing the app and transmitting it over to the device. If you don't have a Fitbit device, you can still do Fitbit apps development. We are also implementing and maintaining a Fitbit OS simulator, which is constantly updated to include the new launch devices. So developers can actually get a glimpse of what their app looks like, even though they don't have a real device. Next slide, please. And it all boils down to what the developers see. They have access to the developer documentation. The main entry point for that is .fitbit.com, containing API reference that's available from device, from the companion, various tutorials, various mechanisms, the new additions, blog posts, and everything that's related to this developer environment. Since the developers can opt to use TypeScript, which uses type checking, we are also implementing the APIs that are available to developers as a set of TypeScript definitions, so that in their apps, developers can do type checking on their apps and making sure that everything is working according to spec. Also, as a general guideline, when we're developing the APIs, we're ensuring backwards compatibility. We're deprecating the latest SDK that are available to developers to develop with. But essentially, once the applications are deployed to gallery, we are ensuring that applications still run on the latest devices, even though the SDK version gets updated. We're still maintaining backwards compatibility with the applications that are already deployed to gallery, so that they're still functional on their most recent devices. And having this covered, I will let Alex take back and go through the flow from start to end related to how to develop an app.
Thank you. Hi. So in this section, we'll be looking into how an app is born and how you can get yours to users. Like any app, you start with an idea. It can be anything from showing the weather, communicating with other devices on the network, showing sensor statistics, or even launching rockets from your wrist if you're into that. When you have your awesome idea, you should definitely read our documentation over at dev.fitbit.com and see what's available. This, as Bogdan said, this page points to all the necessary documentation required for a developer to start building an app. Here you can find comprehensive API references, guides, various walkthroughs of how certain mechanisms work, as well as more info about an app's general architecture. When it comes to the actual coding, you can either choose to develop using Fitbit Studio or our CLI tools together with your favorite editor. Since any developer would like to see his code running, you can always sideload apps and clock faces by connecting your phone and device to the dev bridge Bogdan mentioned a few slides back. If you don't have a device available, you can always use the Fitbit simulator for both device and mobile. When your code is ready to ship, you can upload the build to the Gallery App Manager and submit it for review. Once your submission has been approved, you can publish your app or clock face so that it's readily available for everyone to enjoy. That's basically it from an idea to actually publishing. I'm going to turn it back to Bogdan.
Cool. Sounds awesome. Okay. So having presented all our development ecosystem, we will now go a bit into depth into a case study with our most recent feature we've been developing using the SDK. What's particular to this feature is that it's a health-specific feature, and this is the SpO2 measurement or oxygen saturation at the blood level. This is a feature that has already been launched in our existing Fitbit smartwatch family, meaning the existing devices in the market such as Ionic and the Versa family. And it also supports the new devices we've just launched, the Versa 3 and the Sense, which we're delivering to our users this fall. What's particular to the SpO2 stats feature is that it's targeting the users that are opting for the health focus package. And basically, working on a health-specific feature brought us a new world of requirements around it, which we had to satisfy using our existing components. Essentially, when working with the customer's health data, there are a lot more regulations and processes in place that we need to follow before actually enabling this feature to our users than there will normally be for a normal clock phase that just displays the time and some other basic stats, so to speak. There's also a lot more care that we had to put in on how the applications handle communication with user, and a higher level of quality and attention and robustness is required here. Next slide, please. This is what the feature looks like. So it's a clock face the users can install on their wrists. It shows the normal features that a clock face would show, such as the time and the date. It also shows some Fitbit already known stats, such as the heart rate and the steps. And additional to this, it also has a screen where it shows the SpO2 measurement. Many recent studies carried out worldwide start to show the correlation between the oxygen saturation levels and COVID infections. There's still a lot of clinical work going on around the world on this, but the feature itself and the measure itself is becoming more and more relevant. And basically what we did is that we used our Fitbit SDK to develop this feature and enable it to our users. Next slide, please. So regarding the requirements I was telling you about, one of the main requirements we had was to enable this feature and make it available to specific portions of the entire user base. This is used in like multiple areas in processing and the development of the feature. So one area is is related to testing, because testing this feature entails not only testing the SDK features itself in terms of accessing the Fitbit-specific components on the device, but it's also a joint collaboration with the research team for them to be able to iterate on the algorithm processing based on the data they're gathering and the users participating in it. So many times we had to do a build of the feature of the app and just enable it for specific portions of the user. There's also, once, let's say, the feature is tested and it hits the numbers it's supposed to hit in terms of reliability, there's also the medical regulations which need to be satisfied. So based on discussions with the regulatory authorities that are different and specific to each portion of the globe the user lives in, we need to enable this feature differentially in different periods of time at specific at specific dates as these regulatory processes get carried out. Last but not least, since it's sensitive data that's belonging to the user, we need to give the end users, the possibility to opt in and opt out of this feature. So this feature is not enabled by default. User need to specifically agree to participate, basically to enable the gathering of their data in order to have this processing available. As I mentioned, because this is sensitive data, we're looking a lot at its accuracy. So we need to make sure that we feed the algorithms the right type of data gathered in specific conditions. And we also need to make sure that that data is protected, both in communicating to the rest of our ecosystem, and in case there's a failure or there are errors, we need to identify them early on so that we don't particularly take them into account, so the system stays in a robust state. Aside from that, as I mentioned, since it's a feature that's subject to many iterations in the development, we want to work on this feature and refine it independent of the firmware release cadence or the mobile application development and release cadence there as well. Next slide, please. Talking about deployment and availability of the feature, from the entire ecosystem Alex presented a bit earlier, this is handled on the gallery side. So that's part of our of the Fitbit cloud. It's implemented in services there. And via the gallery, we can define the groups of association between a specific app, so for the SPO2 feature in particular, and specific user groups which get that feature. And having this feature on the gallery side, we can allow all the feature or all the requirements that are related to deployment and availability. So based on this, we can allow specific or out. We can enable various stages of testing, both before the release and after. We can conduct clinical trials even after a feature has been released. We can then continue iterating on the algorithm and how it behaves on new and new sets of data. And we can also work in a joint effort with other companies or internally in the company with other teams in sort of like partnerships. Partnerships can be used to develop second-party apps that use the Fitbit SDK, and they can also be used to provide content on the devices for educational purposes, so to speak. Regarding this latter use case, there have been announced some partnerships with medical institutions in the recent press, I believe, end of last year or so. Next slide, please. Okay, so in terms of iterative development, having an SDK that provides a consistent surface of APIs on a family of devices allows us to do the iterations just for the app. So we can release a new version of the app that already uses the existing SDK functionality. At Fitbit in the past years, the normal cadence for releasing a new device or releasing an update for a device is like 2 or 3 per year, because it entails a lot of testing, a lot of development, and a lot of regression just to make sure that devices don't break on the user's wrists. Developing and iterating to versions of the app happens much quicker. It can be targeted and contained just for that particular feature. Therefore, by doing this, we're easily integrating new information from the field. For the particular case of the SPO2 feature, this can involve findings in the new medical studies that are happening worldwide. We can integrate the test results from the recent field studies, and we can generally address user feedback more rapidly when it belongs to the app itself and not the platform. Next slide, please. Also, by decoupling the SDK from the operating system underneath, we're basically controlling how the app interacts with the overall platform. We're making sure that each app runs in the contained environment so that we can identify misbehaving apps and make sure that they don't affect the entire running and well behavior of the entire system. We're ensuring behavioral consistency, and we're making sure that different applications don't have access to the same data. So basically, we're benefiting from everything that sandboxing offers us. And also, being decoupled from the OS, we're also ensuring that the SDK is portable and can be enabled on the new devices. Next slide, please. Also, by integrating with the Fitbit ecosystem, we're benefiting from all the communication channels that are already exposed to applications, and these are fairly mature at this point. Here we're talking about tracker to mobile application communication and communication with the mobile app to our cloud services. For the particular case of SPO2, we're kind of marking all the channels, I believe, in terms of data gathering and storage, all the way to the backend where it's protected. Authentication and security. We're not implementing any special communication endpoints or communication channels that are particular to a specific apps. And instead, we're using the ones that are already developed and mature and robust. And we're also offering a quick and uniform data path for analysis with the data that's taken from the user's wrists all the way to the Fitbit services, which are feeding into the research team's algorithm development. Next slide, please. So in terms of value, what's the value to the end user? The end user, by using and reusing the same components, is getting a consistent experience when running the device. It's an easy and fairly intuitive to use app. It's visually appealing. All the processing that's related to SPO2 happens in the background, so we're taking care of using our ecosystem to do this processing. All the user needs to do is to opt in, enable or disable the feature, and then all the monitoring is being handled by standard Fitbit components. We're integrating in the ecosystem. We're making sure that as the ecosystem evolves, we're benefiting from the latest addition. We can do data analysis from large portions of the user base, and we're basically offering a connected experience that spans across the smartwatch and the mobile app and the Fitbit cloud itself. Also, this experience can be customized, ranging from some basic stats information of SPO2 all the way to in-depth analysis and trend measuring over multiple days. Next slide, please. In terms of our internal value, so why we're benefiting from using the SDK, I guess the most important benefit here is that we can use tighter iteration loops. We're by using the standard components, we're able to do rapid deployment to the user portions we're involving in various field studies. We can gather and analyze the data in a consistent way. We can enable and drive this custom user-tailored experience, and we can iterate. There's a quick reach from the application itself to our systems which analyze it. And users can report the issues early, and we can look at the data and see how it looks like, so we can iterate on the algorithm. And doing this tight client feedback loop, we can feed into an increased engagement in our user base, because users can see that they're actually heard and their feedback is taken care of and integrated without waiting for weeks or months before getting a new release of the app. Okay, I think that's most of the content we had prepared. So thank you for your kind attention, and we're going to leave some room for Q&A now. So we got one question regarding the external development and whether external developers can contribute to the tooling on GitHub. Yep, for the repositories that are available via GitHub, SDK toolchain package, of course, we can take PRs from the community and have them reviewed by the internal teams and have them merged. Looking forward to contributions. So we got a question about whether we can get into a bit more detail how the mechanism of distributing and deploying the apps happens from an architecture point of view. Basically, Alex mentioned a bit earlier about an install service, which is integrated in the Fitbit ecosystem, and that does most of the deployment and marking of the apps to different users, and essentially it's integrated to the rest of the Fitbit ecosystem that takes care to the device communication with its services. So that's when the apps actually get installed. Maybe Alex or Andrei can talk a bit more about this, or if I covered it, it's okay, I guess.
Hey, can you guys hear me?
Yep, we can. Hey.
Hey, nice to see everyone. Yeah, so the gist of it is what Bogdan covered. I think fortunately for further details would make the scope of different talks. So there's another question with regards to app review processes. Do we have automated tools or developers doing it? It's a mix, right? There's some things in the process that you can totally validate using automation processes and like just in general validate them very quickly and you know, binary yes no fits doesn't fit kind of thing going on. But given that the nature of some things can get very complex, just to make sure everything works fine, you often need a human hand in there as well.
One other thing to mention here is that we are doing efforts as we are adding new features to the SDK. We're also looking at ways to integrate the review of those features in the review process, ideally automatically.
Oh, that's a complex one.
Wow.
So the question is, why are we using a clock face instead of a system feature or an app? So users with paid clock faces can keep them. There's a couple components over there. Maybe we should answer them, I don't know, one by one. Or so the main reason it's in a clock, or one of the reasons it's in a clock face is clock faces are very popular. Most of the users would rather just work with and change through clock faces daily, like there's no tomorrow. And it's easier to get them to engage with something like this, especially because it has all the various views. They use it to get their stat, and then they can potentially change to something else more fancy that they need during the day, and then they can just go back to that. or I don't know, if they like the style, they just keep that. So that's kind of a reason why that would be chosen over an app. Also, as Bogdan mentioned during the presentation, the fact that it doesn't really need user interaction to work, just kind of starts working when you don't expect it. You don't need to know when it starts working. That means that, again, you won't need to go in and click buttons and do anything. It just does its job. So those are some of the considerations. Now, as with paid, maybe Vlad, you can give us some clarifications around that, like what you mean. This one is free, so there's no relation to having users to pay or get a subscription or something. This is one of the things that's readily available and users can just go and get.
Yeah, I didn't quite get instead of the feature app, so that users with clock faces can keep them. I personally didn't get that part.
So you can keep the app anyway because it's free. I mean, well, the clock face, right? So.
Yeah.
If you go into Fitbit store, like into our gallery under your device, or whoever has used the application and all that, you'll see that some things are indeed paid, and yeah.
Oh, okay, because it yeah, it interferes with the clock face that's being displayed. Or yeah. Yeah, we probably chose a clock face due to the reasons Andre mentioned, because they're more like readily available all the time and the user has access to the stat at all times. And for having an additional clock, Fitbit devices have the feature of being able to install multiple clocks on device and just browse through them. It's not at the same time as it would be with an app, but yeah.
But yeah, there's no real danger there. I'm playing with it right now just to make sure, seeing random things. But usually, yeah, you have the ability on our smartwatches selection to multiple clocks, even paid ones, as I was mentioning. You can find in the gallery paid ones, and they will, allow you to switch in between them. And you can just go cycle. And as I mentioned previously, if you need your SPO2 to be read and you want to make sure that data is accurate and everything, you select the clock face that shows you the stat and helps you get the stat. Otherwise, you just go back to the clock face you paid. It won't go anywhere. Let us know, Vlad, if that answers. We have one more from Mihaela. During various releases of device SDK versions, they happen to have overlapping regressions for these candidates for different versions. How are these handled from branching strategy point of view? As Bogdan mentioned, usually the SDK support we offer is backwards compatible, and there are API contracts that we offer with our developers. So there is, in terms of branching, it's what eventually ends up being mainline, so to say, doesn't fork out too much. It's mainly gonna be the end product on something that's linear for the versions that we that does add in release regressions in release candidates and so on, because as the guys mentioned in the presentation, this sits on top of Fitbit OS decoupled from it, so there's like two pieces sliding on top of each other. One may go this way, one may go this way. You have to realign and make sure everything is fine before release. So yes, oftentimes you end up needing multiple release candidates, needing to run those regressions against potentially multiple versions underneath the SDK just to see what went wrong, where it went wrong. But eventually, in terms of branching strategy and what ends up in production, because of the promise and the contracts of backwards compatibility, that ends up being pretty linear and pretty additive. So version 2 just adds things on top of version 1. Version 3 adds things on top of version 2. If we ever want version 4 to break something, we need to suddenly start saying, okay, there's a deprecation process first you go through that and then you cut it off and things like that.
Yeah, to add a bit to that, because the question was, did it happen to have overlapping regression and release candidates for different versions? Yes, it happened. And basically, from the diagram that we showed a bit earlier, where we were attempting to decouple the SDK environment from the actual OS that runs underneath, we're doing our best to do testing and integration early on so that we can address these differences between, I don't know, different regressions and different candidates and different versions, so that they can be handled seamlessly. And the developers only sees the API surface, which is consistent across all devices that it's running on.
And we usually give it thorough thought when designing an API so that we can also come in later and add stuff, not remove stuff. Or
a sort of non-official promise towards our developer is we'll try to make things as generic as possible so they don't have to go back and change a ton of things when eventually we decide we need to remove something. If there's any more questions or just chats people want to start, like the question about the t-shirts, just feel free. Thank you, Michaela. Yeah, we try our best because over the years they've become close and they've started putting out some really good content. So it would be a shame to not support them and not keep offering them the ability to focus more on creating the content and getting cool designs out to users, cool ways of using the device, rather than having them worry about, oh man, I have to rewrite hundreds of lines of code just because.
That's a really good question. Is the SDK targeted to developers or designers? Both. I mean, by looking at our community, we're seeing both developers that are trying to use our APIs to enable like all these new use cases and all these new apps. But the largest portion of our gallery is still comprised by clock faces. So with the clock face, we see a big interest in the actual design part of the clock face.
Yeah, plus defining the actual UI as standard SVG, basically.
Yeah.
Which should be very friendly to designers.
We can take this one more question. So there's a question of monetization. Can a developer sell watch faces? The short answer we can give here is yes. As I mentioned previously, if you go into our Fitbit mobile gallery, you can see in our various selections of clock faces, some of them are paid. They will ask for you to, it will even give you like a small notice that, hey, to use this after 10 minutes or something, you'll need to pay. The process through which that happens is a bit more complex and maybe not so straightforward. So that's a longer answer, which unfortunately we won't get to cover. But the short answer is yes. If you're a developer, there are ways for you to get money out of the stuff you build.
Okay, I believe this wraps up our session time. Thanks everyone again for participating. Thank you for your kind attention. Thank you for the questions. I hope this presentation was useful to you. Thank you.
Thank you, Michaela.
And looking forward to having you use the SDK. And keep in touch.
Yep.
Thank you, everyone.
Thanks.
Good night.
Bye-bye. Good night.
Bye.